What's up, Chem peeps? One more empirical and molecular problem. It's a doozy. The analysis of a rocket fuel showed that it contained 87.4% nitrogen and 12.6% hydrogen by mass. Mass spectral analysis showed the fuel to have a molar mass of 32.05 grams. Two things. What is the empirical formula of the fuel? What is the molecular formula of the fuel? All right, let's tackle empirical formula first. Remember, smallest whole number ratio of moles of your elements in the compound. We're given percentages. So the first thing I want to do is assume I have a sample of this compound that's 100 grams. If I assume a 100 gram sample and 87.4% of it is nitrogen, then 87.4 grams of that 100 gram sample is nitrogen. And if 12.6% of that 100 gram sample is hydrogen, then 12.6 grams of it is hydrogen. You could assume any mass value that you want, but 100 grams is going to make the math really easy. All right, now the empirical formula is not the smallest ratio of grams, it's the smallest ratio of moles. So let's convert each of these to moles. Again, these mass values for nitrogen and hydrogen come from the periodic table. So take a quick jump over to our calculator. 87.4 times 1 enter divided by 14.01 enter. 6.24 moles nitrogen. 12.6 times 1 enter divided by 1.008 enter. 12.5 moles hydrogen. Remember, it's a ratio or a comparison of our moles when we're trying to come up with the empirical formula. Easiest way to determine that ratio? Divide each of them by the smallest number of moles. In this case, 6.24. Easy enough here, that's equal to 1. Easy enough here, it's close enough. 12.5 divided by 6.24, especially when we consider sig figs, it's close enough to 2 that we don't have to worry about coming up with a multiple in order to come up with our smallest whole number ratio. So our empirical formula, NH2. Next, let's determine molecular formula for the fuel. We're told that the fuel has a molar mass of 32.05 grams. Let's start with our empirical formula NH2. Its molar mass can be determined from adding together the mass of 1 nitrogen and 2 hydrogen. 14.01 plus 2 times 1.008. The molar mass of our empirical formula is 16.03 grams per mole. Clearly not the same as the molar mass of the actual formula of this compound. Let's determine the multiplier, or let's determine how many times larger the molecular formula is than the empirical formula. To do that, we simply compare our molecular formula, 32.05, to the molar mass of our empirical formula, 16.03. 32.05 divided by second answer. It's about 2 times larger. So my molecular formula is going to have the formula N2H4, or twice the value of the subscripts that we saw in the empirical formula. Is molecular formula. Empirical formula. Just to clarify. Boom, double boom. We are done.